Hi, hello, welcome to our channel JET. Today we are going to discuss the numericals which appears in your physics paper. Right? So let's get started. Module 1. So first module, for the particle executing SHM has accelerating 15 centimeters per second when displaced is 5 seconds. Calculate the time period. So for such question, very simple. We know that A is equal to minus omega square x. So A is given 15 centimeter per second and x is equal to 5 centimeter. So we put omega square is equal to A by x. Same formula, we are rewriting it and we get omega value. Now we know that time period T is equal to 2 pi by omega. So substituting in place of omega root 3 and we get our answer 3.63. Yes, coming to next question. The second question, for SHM with amplitude 13 meters and period 12 pi seconds, find velocity at 5 meter displacement. So we know that V is equal to omega root over A square minus x square. So A is equal to 13 centimeters, x is equal to 5 centimeters, given displacement. So that is x. A is 13 centimeters, the amplitude, we mentioned A, yes, that is 13 meters. T is equal to 2 pi. Okay, so we know that omega is equal to 2 pi by T. So T value is 2 pi. And so omega becomes 1. So V is equal to, substitute in all the places, all the values, you will get 12 meters per second. So if you learn all these questions, whichever I am mentioning here in this video, you are going to get 100 out of 100 in numericals part, right? Just don't skip the video, see it completely. Okay, guys, so let's move on to the next question. Calculate resonant frequency of a simple pendulum of length 1 meter. So F is equal to 1 by 2 pi root over G by L. G is gravity. L is the length. Okay, so pendulum length, they have given 1 meter. We'll substitute 1 meter. Okay, and gravity, you know that it is 9.8 meters per second square. So we'll substitute. After we substitute, we will get it as 0.498 hertz, right? Okay, moving on to the next question. A 20-gram oscillator omega naught is equal to 10 radians per second, okay, with damping coefficient 0.17. Determine if the system is underdamped or overdamped. Okay, so yes, so we have the value omega naught is equal to 10 radians per second and we have the damping coefficient as 0.17. So when the coefficient is less than omega naught, it is clearly known as it is underdamped system, right? So moving on to the next question. For mass 2 kg, spring constant 51.26 nm n/m, damping 5 kg per second, find critical damping value. So critical damping, you know the formula, so C is equal to 2 root over m into k. So it's just substitute the value, you will get the answer as 20.25 kg per second, right? Yeah. Moving on to the next question, shock wave and match number. Okay. So shock wave travels 100 mm in 195 microseconds. Okay. Speed of sound, you know, it's 340 meters per second. Then calculate the match number. Okay. What is the formula for the match number? M is equal to V by V sound. Okay. What is V? Velocity. What velocity is equal to distance by time. So distance here is 100 millimeters. When you're converting to meters, it becomes 0.1 meters. So 0.1 as a distance, time 195 microseconds. So micro means 10 to the power minus 6. So the answer you get 512.82 meters per second. We're going to substitute here and with speed of velocity of the sound. So it becomes 1.51 as your matched number. For shock wave traveling 150 millimeters in 0.3 millisecond, so sound speed is equal to 340 meters per second. Find match number. Okay, you know that match number V divided by velocity of sound, right? So what is the velocity here? So distance by time is velocity. What is the distance traveled? 150 millimeters. 150 millimeters converted to meters, 0.15. Okay. Now divided by time, what is the time? 0.3 millisecond. So 0.3 milli means 10 to the power minus 3. So we are getting 500 meters per second. So when you are substituting that in the place of V, you get 500 divided by velocity of sound, which is 340, which is equal to 1.47. So that is your match number. Moving to the next question. Spring system. So in spring system, you have mass 0.5 kg extended spring by 0.03 meters. Calculates spring constant, angular frequency, time period. Okay, spring constant. Okay, what is spring constant? K, you know that. So F is equal to K into X, you guys know. So you are going to find K, so it will be F by X. You know what is F? It will be M into G, right? Because it's a spring which is under and the force is under gravitational force. So M is M into G. So what is the weight? 0.5. Okay, into gravity 9.8. So you get it as 4.9 newtons. So after substituting that in place of F, you get 4.9. What is the displacement? 0.03, right? So which is equal to 163.33 nanometers. Moving on to the okay, that is spring constant, right? Now angular frequency omega. You know that omega is equal to root over K by M. Yeah, substitute the value of K and M is already given 0.5. You get 18.07 radians per second. And next time period, T is equal to 2 pi by omega. You will get the answer as 0.348 seconds. System with natural frequency 1000 Hertz, damping 0.008 radian per second under 5 Newton per meter force. Find peak amplitude. A peak is equal to F naught divided by 2m. This is the symbol for your damping, okay, into omega naught. You have F naught as 5 newtons, and your damping value as 0.008. Omega naught, we'll take it as 2 pi into 10 to the into 1000, which gives 6283 radians per second. M is equal to 1 kg, which is, since they have not given mention about the weight, we are assuming it as 1 kg, right? Okay, after substituting, you will get 0.0497 meters. Next, classify speed as subsonic, supersonic, or hypersonic, right? Okay, so 2000 kilometers per hour, when converted to meter per second, you get it as 555.56 meters per second, which is nothing but when divided by 340, get it as 1.63. 340 is nothing but velocity of sound. Okay, 1.63 is nothing but your Mach number. When your Mach number is more than 1, it means it is supersonic. When it's less than 1, it is subsonic. As simple as that. Next question. An electron is bound in one-dimensional potential well of with 1 Armstrong. Calculate energy value for ground state and first two excited states. Okay, so for particle of one-dimensional infinite potential well, En is equal to n square h square divided by 8 ml square. So when you know h value, you know m value, you know L value, substituting all this, you will get En. But what is N? N for ground state, which is E1. So for E1, you will get it as 37.6. Okay, so for first two excited states, you have to calculate E2 and E3, right? So you get the values for that respectively. Now going to for De Morgan wavelength 3 Armstrong, calculate energy of neutron. Okay, so lambda is equal to h by p. You guys know energy is equal to p square by 2m. So p square again can be written as h square by lambda square. In place of p, you are substituting h by lambda, right? So after substituting and replacing all the values, we'll get it as 0.091 eV, which is electron volt. Electron accelerated through 2 kilovolt potential. Find de Broglie wavelength and velocity. Yes, okay. So mass is given as 9.1 into 10 to the power minus 31 kgs. Yes. Okay, that is nothing but mass of electron. Yes. Now coming to the formula, E is equal to electron volt, which is okay, which is equal to 2 into 10 to the power 3 into 1.6 to 10 to the power minus 19. So which is equal to 3.2 into 10 to the power minus 16 joule. Okay, lambda value, similarly, you know that it is h by root over 2m ev. So when substituting all this, you will get 0.0273 nanometers. Velocity v is equal to root over 2 ev by m. Substitute all the values, you will get 2.65 into 10 to the power 7 meters per second. Yeah, coming to module 3, optical fibers. Okay, numerical aperture and acceptance angle is given. Okay, core refractive index n1 is equal to 1.50, cladding refractive index 1.48. Okay, find numerical aperture and acceptance angle. Okay, so what do you have to do? So n1, which is the core refractive index, which is 1.50. Cladding values are given 1.48, right? Refractive index value. So you know numerical aperture is equal to root over n1 square minus n2 square. Substitute the values, you will get 0.244. And you know that acceptance angle is theta A is equal to sine inverse of numerical aperture. When substituting the numerical aperture inside that, you will get 14.13 degrees, right? Attenuation in fiber. Okay, given what is given? Initial power P0 is equal to 100 milliwatt. Output power 90 milliwatt. Fiber length L is equal to 500 meters. Okay, attenuation. Okay, in dB per kilometers. Note the point. Okay, so attenuation is equal to 10L, 10 divided by L, log of P0 by P base 10. So substituting all this value, you will get 0.92 dB per kilometers, right? Since P0 is given, P is given, L is given. So this is the formula. If you guys don't know, just memorize the formula. Okay, it will be really helpful, right? Okay, guys. Okay, moving on to the next question. So V number and modes. Okay, these two you have to find out. Okay, as simple as that. Okay, so given core diameter is 50 micrometers. N1 is equal to 1.45, N2 is equal to 1.40, lambda is equal to 820 nanometers. Okay, so find V number and number of propagation modes. Okay, so what we are going to do, given all these are given. Okay, first we have to find numerical aperture, right? Okay, what is numerical aperture? N1 root over N1 square minus N2 square. So you get 0.377 and V. What is the number V? Okay, so you have to formula 2 pi a into Na divided by lambda. To get this Na value, we have calculated it from N1 and N2 refractive indexes. Okay, so after substituting all these values, including lambda, is given the question, you get 72 as your answer for V number. So number of modes, you know, it is V square by 2. Substitute it, you will get 2592, right? Okay. Yes. Moving on to the next question, you are finding fractional index change. What is fractional index change formula? Delta is equal to n1 square minus n2 square divided by 2n1 square, right? So what is given here? N1 is given, delta is given. You have to find n2, which is the cladding refractive index. Okay, using the formula fractional index change formula, right? So you're finding the n2 value as 1.524. Yes, moving on to the next question. You're having laser wavelength as 780 nanometers, pulse power is 20 milliwatt, pulse duration is 10 nanoseconds. Okay, find the number of protons per pulse. Okay, so you have the formula E is equal to P into T. Guys, just memorize the formula. This is nothing. P is nothing but power into time. Energy is nothing but power into time, right? Yes, so that is what is given here. So power is equal to 20 milliwatt. So which is milli means 10 to the power minus 3. So you're going to multiply it to 10 to the power minus 3 and duration 10 into 10 to the power minus 9. So when you place these values inside it, you get 2 into 10 to the power minus 10 joules. Okay. So energy of photon, hc by lambda, right? So you know h value, you know c value, you know lambda value, right? Which is given in the question. Okay. Substitute, you'll get 2.55 into 10 to the power minus 19 joules. Okay. The number of photons. So when you're calculating the number of photons, you have to divide the total energy divided by the energy of photon, a single photon. So you get number of photons. Okay. So what you're getting, total energy by number of photon value as 7.84 into 10 to the power 8 as number of photons. So these many number of photons are present. Right. Moving on to the next question, you know that energy of a potential well is already we have discussed n square h square by 8 ml square. Okay, right? So now what are they asking? So given that its width is 1 Armstrong. Okay. Okay, what we have to find out is the energy difference between the first and the third excited state. Energy difference of first means E2. The energy of third excited state means E4, right? So we have to find difference, meaning E4 minus E2, right? To get E4 minus E2, we are going to substitute n value as once 2 and another time as 4, right? And width is anyway given, okay? So just we are going to substitute and we're going to find, right? So once you calculate, you will get E1 and E2 and E4 value, and then substitute, you will get 12 times E1, right? Okay. Now, photon count from energy. So lambda is equal to 5500 Armstrongs. Okay. Energy is 1.5 joules. Okay. Number of photons. Same question we have already done in the above. It's the same one. You can just go through, right? Okay. Let's move on to module 4. Okay. We are calculating the Fermi level probability. Okay. F of E. That is how you represent it. Okay. Now, what is given to us? 0.02 eV. Okay. Electron volt. Above Fermi level at 200 Kelvin. Probability of occupation. Okay. What is the probability of occupation? 1 by 1 plus e power e minus ef by kt, right? Okay. Slowly we're going to substitute all of these. Okay. So E value, energy level given 0.02 eV. Next, you're going to substitute. Yes, that is the energy level. Meaning you have to, that's the value of the difference value. E minus EF value is 0.02 eV. Okay. And next, K value, you know that it's a constant. We're going to Fermi level constant, which is 8.617 into 10 to the power minus 5. Okay. T is nothing but temperature, 200 Kelvin. So we're going to substitute and use the scientific calculator, and you will get the answer 0.238. So in the module 5, what is given? Polarizability is 7 into 10 to the power minus 40 farad into meter square, right? Okay. And density, atomic density is 3 into 10 to the power 28 atoms per meter cube. Okay. Calculate the dielectric constant. Okay. Now you know that the dielectric constant epsilon naught R is equal to 1 plus n alpha epsilon naught, right? Now you know value of n, right? Which is nothing but atomic density. And electronic polarizability value alpha, you know the value. You're going to substitute. You know epsilon naught value 8.85 into 10 to the power minus 12. Guys, you know, otherwise you have to memorize it. Okay. Substitute all these value, we'll get answer as 3.37. Next. Next, you have to calculate polarization produced. Okay, done. Okay, now dielectric material, you know, epsilon R is equal to 6. Okay, in dielectric field, 500 volt per millimeter. Okay, okay, guys. So you know that for polarization produced, which is P, is equal to epsilon naught into epsilon R minus 1 into E. Okay, what is E? 500 V divided by volt divided by millimeter. So which is equal to 5 into 10 to the power 5 V by M, right? So millimeter you are converting to meters. So you will get it as 5 into 10 to the power 5 V by M. So substituting all these, you will get answer as 2.21 into 10 to the power minus 5 C by M square. Hall effect. Okay. In Hall effect, what do you have to calculate? Charge carrier concentration and mobility. Okay. Now, semiconductor with conductivity 112 ohm meter. Okay, inverse. Okay. Hall coefficient 1.25 into 10 to the power minus 3 is given. We are going to substitute conductivity. Sigma is equal to 112 ohm meter inverse, right? Okay. Hall coefficient RH is equal to 1.25 into 10 to the power minus 3 meter cube per C coulombs, right? Okay. You know that RH is equal to 1 by Qn. So now you're going to shift N here and RH here. So what it becomes, N is equal to 1 by QRH, right? Substitute the values, you're going to get 5 into 10 to the power 21. What is Q? Charge of electron, right? 1.6 into 10 to the power minus 19. So once you substitute, you will get 5 into 10 to the power 21 carriers per meter cube, right? Next, mobility. Mu is equal to sigma divided by NQ, right? So once you substitute all these values, you will get 0.14 meter square, right? Moving on to the next question, which is nanomaterials, right? Okay. So in nanomaterials, nanoparticle surface area given spherical nanoparticle diameter as 10 nanometers. Calculate the surface to volume ratio. Okay. Yes, guys. Okay. You know the surface area of a sphere, which is 4 pi r square. The volume is 4 by 3 pi r cube. You have to calculate in terms of sphere, right? Yeah. So when you're doing surface to volume ratio, 4 pi r square divided by 4 by 3 pi r cube, which comes to a conclusion that 3 by r. This 3 goes up and r square r cube get cancelled and you get r in the remaining. So 3 by r. So what is r value? Is given 5 nanometers. Substitute it, you will get 6 into 10 to the power 8 meter inverse, right? Because r is in the bottom, right? Okay. So thank you guys. All the best for your exam. Thank you.